Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 6 is equal to 27. So to solve this, I'm going to first rewrite this as x to the power of x to the power of 6 is equal to 3 to the power of 3. And now from here, this is the same thing as x to the power of x to the power of 6 is equal to the cube root of 3 to the power of 3 to the power of 3. Which is equal to the cube root of 3 to the power of 3 squared. Because 3 times 3 is 9, and 9 is the same thing as 3 squared. Now from here, I get x to the power of x to the power of 6 is equal to the cube root of 3 to the power of the cube root of 3 to the power of 3 to the power of 2. And this is equal to the cube root of 3 to the power of the cube root of 3 to the power of 6. Meaning x is equal to the cube root of 3 because it's in the form x to the power of x to the power of 6. So x in this case is the cube root of 3. Alright, so in this problem, I have 3 to the power of x is equal to 80. So I want to find the value of x here. So for my solution, I first start with 3 to the power of x is equal to 80. And now I'm going to take the log on both sides. So I get log 3 to the power of x is equal to log 80. Now, we want to find a way to, we want to find the value of x, right? And to get x, it's hard to do it when it's in exponent form. So we want to find a way to bring x down to make it a real term. And to do that, there is an important property of logarithms that states that if there's something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So now I have x times log 3 is equal to log 80. Now from here, I'm going to rewrite 80 here as 8 times 10. And if I have something in the form log a times b, this is equal to log a plus log b. And this is another one of the logarithmic properties. There is also log a over b. And if I have something in this form, this is the same thing as log a minus log b. So now going back to the problem, we have log 8 times 10, and we can use this property. So we can think of 8 as a and 10 as b. So this is going to equal x log 3 is equal to log of 8 plus log of 10. Now, if you guys already didn't know, log 10 is simply equal to 1. So I get x times log 3 is equal to log 8 plus log 10. Or sorry, just 1. And now remember, we want to isolate x, so the only thing left to do is to get rid of this log 3 by dividing both sides by log 3. So this cancel out, and I get x is equal to log 8 plus 1 over log 3. Now, log 8 is equal to 0.90309, and log 3 is equal to 0.4771. So this is going to equal 0.90309 plus 1 over 0.4771. And this is equal to 1.90309 over 0.4771. Now 1.90309 over 0.4771 is equal to 3.9889. So x is equal to 3.9889. Now, the only thing left to do is to check if my solution here is correct. So the original equation was right here, 3 to the power of x is equal to 80. And my solution is x is equal to 3.9889. So if I plug this in for x into my original equation, I get 3 to the power of 3.9889 is equal to 80. Now 3.9889 is really close to 4, right? So let's first find the value of 3 to the power of 4. 3 to the power of 4 is the same thing as 3 times 3 times 3 times 3, which is the same thing as 9 times 9, which is equal to 81. Now 3.9889 is a little less than 4, meaning we can estimate that it's going to be around 1 less than 81. So it's safe to say that 3 to the power of 3 to the power of 3.9889 is close to the value of 80.